Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from integrals, right? And in this class we are going to discuss this integral, right? So here we have to evaluate this integral from 0 to 2, and our integrand is x square over square root of 2 minus x, right? So here again, we'll make use of the concept of beta gamma function, right? So let us start and let us take this integral as I, right? So viewers, what we will do here, will again make use of the method of substitution, right? And the method of substitution is a very powerful method in integration. So here, what we will do, we'll take x is equal to 2t, right? So this is the most appropriate substitution in this integration, right? So we'll take x is equal to 2t. Why we have taken x is equal to 2t? Because see, in the denominator we have the term inside the square root sign as 2 minus x, right? So when we take x is equal to 2t, then we have 2 minus 2t, right? And now we can easily take 2 common, right? So here we have 2 1 minus t. Okay, so now we'll take x is equal to 2t. So dx over dt, that is differentiating both sides with respect to t. We have the derivative of t with respect to t as 1. So we have 2, right? So now we can write dx is equal to 2 dt. Okay, so now here the limits of integration vary from 0 to 2. So we have to change the limits accordingly. So when x is equal to 0, then we can find out the value of t from this relation, because we can also write t as x over 2. So t is 0 over 2, that is simply 0. And when x is equal to 2, we have t is equal to 2 over 2, that is 1, right? So now we can rewrite this integral I in terms of t. So we have now limits of integration going from 0 to 1, and x square can be replaced by 2t square, and here dx can be replaced by 2 dt, right? And in the denominator we have square root of 2 minus x is 2t. Here we have 2t, right? So we can take the constant terms outside the integral. So here 2 square is 4, 4 2s are 8. So we have 8 here, and we have 0 to 1, and in the numerator we have t square. This is dt, and if we take 2 common, then we have square root of 2 outside the integral, and in the denominator we have square root of 1 minus t, right? Okay, so now we can simplify, or we can rewrite this integral as 8 over square root of 2, 0 to 1. We have t square, and square root of 1 minus t can be written as 1 minus t raised to half, and taking this denominator to the numerator, we have 1 minus t raised to negative half, right? And here we have simply dt. So now we have this integral, right? So now we wish to convert this integral into the beta function, or the beta integral, or which is also known as Eulerian integral of first kind. So we have 8 over square root of 2, 0 to 1. T square can be written as t raised to 3 minus 1, right? And 1 minus t raised to minus half, which can be written as half minus 1, and dt, right? So we have expressed t square as t raised to 3 minus 1, because this is going to be our m, and minus half is written like this, half minus 1, this is going to be our n, right? Because see, the beta integral or the beta function is defined as 0 to 1 x raised to m minus 1, then we have 1 minus x raised to n minus 1, here we have dx, right? So comparing this integral with this one, we have m is equal to 3 minus 1, this is m minus 1, so m is 3 and n is half, right? So here we have half. So now this integral I can be written as 8 over square root of 2, then we have beta of m comma n, m is 3 and n is half, right? So now we have to find the value of beta 3 comma half. So now in order to get the value of beta 3 comma half, we'll make use of this result. Beta mn is the relation between beta function and gamma function is gamma m gamma n divided by gamma of m plus n, right? So beta 3 comma half is equal to gamma of 3 gamma of half, and in the denominator we have gamma of m plus n, so 3 plus half is 7 over 2, right? So here we have gamma 7 over 2, right? Now see, gamma of 3 can be written as simply 2 factorial, which is 2, and here gamma half can be replaced by square root of pi, but we'll cancel it out from the denominator, right? Now see, gamma of 7 by 2 can be written as gamma of 5 by, we can write it like this, 5 by 2 plus 1, right? So this is 5 by 2, gamma of 5 by 2, right? And further we can write gamma of 5 by 2 by writing 3 by 2 gamma of 3 by 2, and then we can write 3 by 2 gamma of 3 by 2 as half times gamma of half, right? So this quantity is equal to this expression. So here we have made use of this result, that is gamma of n plus 1 is equal to n times gamma of n, right? So here 7 over 2, so we have written 7 over 2 as 5 by 2 plus 1, so our n is 5 by 2, so we have 5 by 2, that is n times gamma of n, that is gamma of 5 by 2. So successive application of this formula leads to this expression, right? And here we have written gamma of 3 as 2 factorial. 2 factorial is simply 2, and here we have made use of this result, that is gamma of n plus 1 is equal to n factorial, right? So 3 can be written as 2 plus 1 and n is 2, so we have 2 factorial, right? So now we can write 8 over square root of 2, and beta 3 comma half is now equal to gamma of 3. Gamma of 3 is 2 factorial, which is 2. Then we have gamma of half, and then we have gamma of 7 over 2, which is 5 over 2 times 3 over 2 times half, and here we have gamma of half, right? So now these two terms get cancelled, right? And always remember that gamma of half is equal to square root of pi, right? Okay, so now we can simplify this expression. This is 8 to the 16 over root 2, and we have now 2 to the 4 to the 8. We can take 8 to the numerator, and here we have 5 3s are 15, right? So now we can have here a 16 8s are 128, and this is 15, times square root of 2, right? So the value of this integral is 128 over 15 times square root of 2. So we can also express this result by rationalizing the numerator and denominator by square root of 2. That is 128 over 15 root 2 times root 2 over root 2. So here root 2 times square root of 2 is 2, and we can cancel 128 by 2, that is 64, and here we have root 2 and this, and we are left with only 15, right? So the value of this integral may also be taken as 64 root 2 divided by 15, right? So viewers, this is how by making use of the concept of beta gamma function and their properties, we can evaluate these kind of integrals.